Welcome back. So, we're in part 3 of our series, and this is where things get really exciting. We're going to take that leap from the drawing board to the workbench. It's all about the practical steps. How to turn your circuit diagram into an actual, physical device you can hold in your hands.
Okay, so let's just dive right into it. This is a question that, trust me, every single person who makes things has asked. You've got this awesome idea all mapped out on paper, the schematic looks perfect, but what now? How do you actually turn that into a real, working project without just getting totally lost in all the component choices out there?
Don't worry, we're going to walk through this together in 4 really clear steps. By the end of this, you're going to feel way more confident about picking the right parts and really bringing your ideas to life.
All right, first things first. Before you even think about buying a single component, let's talk about your toolkit. Gearing up for success means having the right instruments on hand. And this isn't just about making things easier. It's about being able to see what's actually going on inside your circuit.
Think of this as your essential starter pack. You've got a multimeter to measure things like voltage and current, a power supply to, safely power your project, a continuity tester, which is just a lifesaver for finding broken connections, some good tweezers for handling those tiny parts, and if you're working with digital stuff, a logic probe is a super simple tool that just tells you if a spot is on or off. Really, this is all you need to get started diagnosing what your circuit is doing.
And this quote really frames it perfectly. You shouldn't think of these tools as just an expense. They're an investment in your time and in your project actually working. Learning how to track down problems methodically is probably the most valuable skill you can build.
Okay, let's move on to probably the most critical choice you're going to make for any project, picking the power supply. This is literally the heart of your circuit. If you get this wrong, best case scenario, your project just won't work. Worst case scenario, you could see a little puff of smoke, and that's never fun.
So to make sure that doesn't happen, we can break it down into this simple 3-step process. If you follow this, you'll land on the right choice every time, and you'll make sure your circuit has a steady, reliable heartbeat.
All right, step 1 means you have to become a bit of a detective. You need to look at the data sheets, the official specs, for everything in your circuit. For example, a little microcontroller might need a really stable 3.3 volts, but the beefy LED driver it's controlling could need 12 or even 24 volts. Then you add up all the current needs to make sure your power supply can handle the total load without even breaking a sweat.
Now this table shows the big trade-off you're going to face. On one hand, you have linear power supplies. These guys give you super clean, low-noise power, which is perfect for sensitive things like audio equipment. But on the other hand, you've got switching supplies. They are way more efficient and much smaller, which makes them the go-to for anything high power or portable, where you need to squeeze every last drop out of a battery.
And last but definitely not least, whatever you choose, do not skip the safety features. Seriously, think of these as your circuit's own personal insurance policy. Overvoltage, overcurrent, and short-circuit protection. These are the things that are going to save both your power supply and all your precious components from any unexpected electrical oopsies.
Okay, so our power is sorted out. Now we got to figure out how to connect everything together. And look, those little colorful jumper wires are great when you're messing around on a breadboard, but they are not a permanent solution. We need to think about making solid, secure connections that'll last.
And that's where connectors come in. A good electrical connector does way more than just join 2 wires. It gives you mechanical security, so things don't just fall apart. It ensures a stable flow of electricity, and it can even protect your connections from stuff like dust or moisture.
Now, the world of connectors is absolutely huge. But honestly, for your first few projects, you're probably going to run into these 2 basic types more than anything else. So let's just take a quick look at them. Terminal blocks are just fantastic. They give you this really robust spot to connect your wires, usually with just a simple little screw. They're absolutely perfect for connecting your main power source to your circuit board, or for wiring up things like external switches and control panels.
And then you have these guys. You've seen wire-to-board connectors everywhere, I guarantee it. Inside your computer, your TV, you name it. They let you plug in a whole bundle of wires all at once, which makes them perfect for connecting things like sensors or displays to your main board in a really clean and organized way.
So, you've done it. You built your prototype on the breadboard, you powered it up, and it works. That is a huge moment, seriously. But a breadboard circuit is fragile, it's temporary by design, so now it's time to talk about making your project permanent and reliable.
And this feeling right here, it's universal. We've all been there. A breadboard is like an electronic sketchbook. It's awesome for trying out ideas quickly and making changes. But you wouldn't frame a rough sketch and hang it in a museum, right? For a finished project, you need something way more durable.
And that brings us to the perfect next step, the strip board. Sometimes it's called Vero board. It looks a lot like a breadboard with its grid of holes, but on the back you have these copper strips. You stick your components through and then you solder them to the strips, creating a much more secure and permanent circuit.
This comparison just nails it. The breadboard is your sketch pad. It's fast, it can be a little messy, and it's super easy to change. The strip board, on the other hand, is like your first proper draft. It takes a bit more planning and the commitment of soldering, but what you get in the end is a mechanically solid circuit that's perfect for one-off projects.
And hey, once you get comfortable with strip boards, don't be scared of the idea of designing your own custom printed circuit boards. I mean, these days services have made it so incredibly affordable. You can get professional-looking boards made for just a few bucks. It's a total game changer, even for hobbyists.
So to wrap it all up, if you start with the right tools, you take the time to choose your power source correctly, you use good solid connectors for reliability, and then you graduate your design from a fragile breadboard to a sturdy strip board, you are absolutely on the right path from having just a diagram to a durable, working device.
And that is the next big question, isn't it? You've built the thing, but now you have to test it. So join us for our next explainer, where we're going to dive into the really essential skills of testing and troubleshooting your brand new creation. I'll see you then.